right, let's solve some equations now using our nth roots to do that. And what we're looking at are pretty basic equations. They're not polynomials. Get in the sense of x cubed, x squared, x constant. They're going to contain is kind of a degreed term and numbers. Okay, if they have multiple x terms with different powers on them, this strategy is not going to work for us. But with these examples, it should be enough just to use an nth root to get x by itself, and then we'll think back to how many values or solutions does that thing generate for me. Okay, we do know the fundamental theorem of algebra at this point, which means if it's degree 3, there are 3 solutions, and eventually we'll start coming up with all those. But right now, we're just going to look for the real solutions. So we just want real solutions to these equations, and we'll discuss kind of what it means when we only find one, if it's degree 3 or whatever, as we go here. So x cubed equals 125. We're trying to figure out what number cubed equals 125. Probably some of you can do that in your head, but just the algebra behind it would say we want to get the x cubed by itself. And if we can do that, we're going to eliminate this power by taking the appropriate root, which would be the kind of the matching root, right? So what we do is we take the cubed root of both sides of this equation. Okay? And if you think back to one of the previous videos, we know if we're taking a cubed root, there's only one solution to that. We don't include that plus or minus. We just go with what we got. Okay, so the cube root and the cube just cancel each other out on the left. And that will bring down our x then, and that's then equal to the cube root of 125. If you're unfamiliar with those roots, remember we can go into math and come down and use the cube root option. Cube root of 125 is going to give me 5. You would also have the option of using, rational exponents. This is the same thing as 125 to the 1/3 power. So if you don't want to have to go into the menus, you're more than welcome to use the exponents. But either way we look at it, we get an answer of 5. Okay, so x equals 5. And when that index is odd, when you're taking the odd powered or odd root of something, it's just one answer. There is only one answer. Okay. Now again, this thing is degree 3, which means there should be 3 answers. Okay. According to that fundamental theorem of algebra, we only found 1, which kind of would lead us to believe that there's 2 complex roots in that, or zeros in that function somewhere, that we would potentially want to find also. And we will, but we won't do it today. Number 2. We have 3x to the 5th equals -3, so we do have kind of that setup now where we just have a variable x to a power. There's no other variables in the problem, so we're going to try and solve this one. To do that, we have to isolate the x to the 5th power. Right now, this is 3 times x to the 5th, so we want to separate those two. We want just x to the 5th, and to do that, we'll just divide both sides by 3. The 3's cancel each other out. We get x to the 5th then is equal to -3 divided by 3 is -1. Okay. The next step would be to address the exponent. Once we get the x to the 5th by itself, we're going to get rid of it, and we're going to do that by taking the, in this case, 5th root of both sides. So we'll take and apply the 5th root. Negative under a root there. Watch out. Oh, it's odd, so we're okay. Remember, if that had been an even integer or even index there, we'd have had an issue with coming up with a number that when multiplied by itself an even number of times gives us -1. But because it's odd, we're fine. Hey, the 5th root and the 5th power just cancel each other out, and that's going to isolate our x for us. So we'll get x then is equal to the 5th root of -1. Again, you have the calculator there, but hopefully we can come up with this one off the top of our head. What number times itself 5 times is going to be equal to -1, and it's going to be -1. Remember, if the number underneath an odd index is negative, your answer should be negative as well. Okay, so this one here again only comes up with one value solving it like this, which would tell us then there are probably 4 other complex or imaginary solutions that we could find. All right. Number 3, we have a new example here. We have quantity x plus 4 squared equals 0. It's a little different now. Some of you might think, expand this out, take an x plus 4 times an x plus 4, and you could, but then that's going to lead you back to factoring or quadratic formula. We can actually attack this power of 2 right at where we're at. Basically, we have this squared term isolated. We have the x plus 4, which is all being raised to the 2nd power. We have that by itself. So we can actually start this one by taking the square root of both sides. Okay, this is the scenario. We're taking index 2 here. We're taking the square root, so we do have to put that plus or minus sign out there to make sure we get both answers. But this is the case where we end up with a 0 underneath there. So same thing happens here. The square root and the square cancel each other out. Bring down the x plus 4. And that's equal then to plus and minus 0. Well, in this case, that's just 0. So we got one more step here, and that's just a minus 4 from both sides. And we'll get x equals negative 4. Okay. Again, only got one answer there, but if we did look at this one's graph, we would see that it's kind of one of those ones where it sits right on the vertex. This is a repeated solution. It would happen twice in that particular function there. All right, number 4, the last one here. We gotta do some manipulation on this one. We would want to start by adding 7 to both sides. We got to isolate the x to the 4th power. So we'll get x to the 4th then equals 10,000, it looks like. Okay, and then we'll just go ahead and get rid of the power. So we'll take the appropriate root of both sides, which in this case it would be the 4th root. So we're taking an even root. And anytime we take an even root, we got to remember to put that plus or minus sign in there. Okay, 4th root, 4th power just cancel out. We'll bring down the x. Is then equal to plus and minus with a 4th root of 10,000, or what number times itself? 4 times equals 10,000. Remember, you can go to the calculator if you're struggling with that algebra, but it's just 4x root 10,000. Should we get enough zeros there? Hit enter, and that would be 10. So we're looking for 10 here. And then because it was an even root, we put plus or minus 10 in there, and we do get 2 different solutions there, positive 10 and negative 10. It is degree 4, which means we probably have 2 complex roots as well. All right. One last quick example here, and that's just, not all the roots. Right now we're looking at some pretty easy examples where everything kind of comes out with integers. It's not all roots that we're going to take are going to have perfect values, right? So just looking at an example here, it just says approximate. So now we're just going to get a decimal. We'll also work on reducing these things in exact form. But right now, if we just want an approximate answer, a decimal rounded off to maybe 3-4 decimal places, we can just type these into the calculator. Again, you have 2 options. One is to go into math and use the xth root, which remember you have to type the index first. Math, xth root of negative 1,608.07, and hit enter, and you get negative 7. Or you can raise negative 16,807 to the, remember that's the same thing as a 1/5 power. Okay, either way you get negative 7 for your answer. And again, just they can come out as decimals as well. So let's pretend we took, the cubed root of 303. So what number times itself? 3 times is going to be 303. Again, 303 to the 1/3 power, or you could take the cubed root of it. It's just going to be some number between 6 and 7. Okay, so 6.717 is what we'd round that off to. 6.717. And there you go. So come up with the approximates or solve an exact notation. That's it.